had we? Okay. This is the last assignment for multiple regression. There was only one question, and the question was a professor wanted to see if he can predict final exam grade from more than one factor, from midterm 1, grade midterm 2, and midterm 3 for about 25 students from the past 5 years from his class. So, in the first question, the question was state the regression equation. Now here, there are multiple tables given in Minitab. There is one involving F, and there is a detailed one where you see constant, mid 1, mid 2, mid 3, and you see the word coefficient, and you'll see a number next to each one of them. When you're trying to find the equation, you actually look at the one with the coefficients. Then you say, final exam, here you put whatever the constant, the number next to the constant is, minus 434. So that was the first number here. Plus, then you put the number next to mid 1, and it was 356. So 0, 3, 5, 6, mid 1. And for this one, the number next to it was 543 of mid 2. Plus, last one was 1.167 of mid 3. This here is the equation of regression. In question 2, they wanted you to find R squared and interpret what it means. If you go here in one of these tables, you could see it in multiple locations, in fact. R squared was 98.97%, almost 99%, which is excellent, actually, very good. The way you explain this, you say 98.97% of the variations of whatever the y is, and in this case final exam can be explained by med 1, 2, 3, the x's, or combination of them. So the variation of y can be explained by x's, and the x's you have med 1, med 2, and med 3. Yeah, question 3. Was hypothesis, but now be careful here of how they word it. You want to see if there's linear relationship between some combination of the 3 midterms on the final exam. When they ask for the combination, you actually look at the F table in multiple regression. But if they say, is there a relationship for mid 1, you look here. And there would be a t and a p value for each one of them. So if they ask, does midterm have an effect? You look at the t and the p value for mid 1. Does mid 2? You look at mid 2. Does mid 3? But when they say combination, you look here. So like we always do, we state the hypothesis. In the hypothesis, you say there is no linear relationship between final exam and some combination of mid 1, 2, 3 for all students in the past 5 years in this professor's class. HA, there is linear relation, blah, 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 and make sure to write it in full. Okay, the next step was to talk about the assumptions. The first assumption is linearity, or also called the straight enough. If you look at the mini tab provided, there are 3 pictures given for the scatter diagram of mid 1, mid 2, mid 3. This one, you'll see points going like this, same here, and same here. And by looking at them, you see that, well, yeah, we can fit a straight line. And it would be a straight line sloping up. So what I said for this one, looking at the plots for mid 1, mid 2, mid 3, it seems that a straight line can be fitted that's close to most of the points. So this linearity assumption holds. The other assumption here was the normality assumption. Or nearly normal. Of course, in this one, you look at the histogram, but the histogram was terrible. There's no symmetry, there are gaps. So the histogram showed no symmetry with gaps. In this case, you look at the normal probability. You see if they're within a certain band, but not even. There are outliers. So both of them were bad. This one and this one. This one, they don't look like they're within a certain band, and this one was not symmetric. So I said that doesn't hold. This assumption is violated. The other assumption was equal variances. For the equal variances, you look at the versus fits. Again, is it spread evenly? Yes, it looked like it's evenly spread. The does not thicken. So this one holds. I'm not sure if I talked about the independence assumptions. I think I'm just trying to remember. Maybe I didn't talk about the independence assumption, the fact that the sample was selected randomly. So make sure that if I haven't talked about it, to add it, maybe I forgot. So yes, selection was done randomly. So if the selection was done randomly, then of course you say yes, condition is satisfied. So they're all good except for, of course, the normal, because it was not really looking very good from the histogram or the normal probability. And then what test to use? I'm going to mention this, talk about it again. For multiple regression, if they talk about, do you see a relationship between combination of some of them? If you see combination, you look here. But if they specify one of them, does midterm 1, does midterm 2, midterm 3, you look at the t and the p-value here. So the test would be the F-test from this table, and it was something like 670, and the p-value was 0.000. And then they wanted you to talk about the significance where alpha is 5%. Yes, p-value less than or equal alpha of 5%. We have significant results. Do not reject H0. Do not conclude HA. And then they wanted the conclusion. You say, if assumptions hold, at 5% level of significance, we can not conclude, sorry. Result significant, then reject A0, conclude HA. We can conclude HA. But again, you say what HA isn't worked. We can conclude that there is linear relationship between some combination of the 3 midterms on the final exam for all students in the past 5 years in this professor's class. Good? Once again, combination, the F table. They specify, you look here. The next question was another hypothesis at 5%, does M1 or midterm 1, I think it was midterm 3, increase final exam grade? So this question specifies midterm 3, and in terms of increasing. So first, we put the hypothesis for H0, HA. Since this is midterm 3, you say B3 equals 0, B3 more than 0. And you define the parameter for this one. Let B3 be average increase in final exam grade when midterm 3 increases by 1 unit or 1 grade, following midterm 2 and midterm 3 for all students in the past 5 years in this professor's class. So, the way you explain this is the average increase in y when midterm 3, when that x increases by 1 unit, following the other x's for all sample. Now I want you to make sure, because sometimes I have the tendency of forgetting, make sure that I put 3, that I was talking about 3 the entire time. So I'm not sure if I put 3 or in some section put 1 instead or forgot. I think I did, but just to make sure. Now, then after this, the question was, what's the test and what's the p-value? You pick the test for midterm 3, you pick this test, and the p-value, you pick this number. Test was 293 and p-value 0.008. Talk about